Hi guys, so now we're going to learn about precipitation titration. In our previous chapter, you already learned about the basic concept of titration, and for today's topic is about the precipitation process that involve in a titrimetry. First of all, let me tell you about the expected outcomes from this chapter. You should be able to describe the fundamental of precipitation titration, state the types and limitation of precipitation titration, and also describe the precipitation titration curve involving silver ion. This is the contents. Okay, first, I will explain the introduction of precipitation titration. Next is the types of precipitation titration. In the precipitation titration, we have three types of titration: Mohr method, Vahan method, and also Volhard method. Next is the limitation of precipitation titration. So, in any procedure or in any method, there is always a limitation. So, we need to um, consider that in any titration, there is always a limitation to do an experiment. Okay, and the last one is the precipitation titration curves involving silver ion. In this subtopic, you will learn on how to construct your own titration curves. So, as for introduction, let me explain you what is the precipitation titration. Precipitation titration is a titration of analyte with a standard solution of precipitating agent. In this case, your analyte will be the chloride ion. Okay, so basically for the precipitation titration, we will use for example, silver nitrate. Okay, so in this case, uh, silver nitrate is the precipitating agent. Okay. So basically, titration with silver nitrates are sometimes we call also argentometric titrations. Okay, because they use the silver nitrate there as a titrant. Okay, and basically the endpoint will be determined okay by the appearance of excess titrant or the disappearance of reactant. Okay, so basically this you can observe from the experiment by to see by seeing the color changes. Okay, and also there's a suddenly a bulk of precipitate form okay at endpoint. And what we call as silver nitrate is the precipitating agent, and basically this precipitating agent is most widely used, and it is important precipitating agent for to determine the halogens matter, for example like a chloride ion, bromide ion, and so on. So let's look for the types of titration. So as I mentioned just now, we have three types of titration of precipitation. Okay, so basically when we do a detection of endpoint, okay, for this Mohr method, Vahan methods, and Volhard methods, okay, you can see either the disappearance of reactants or the formation of a new compounds, okay, a new products, okay. So next, we will see, okay, as an indicator, okay, uh, we can see like just like what I mentioned about the formation of precipitate, okay, and also you will observe the changes of color of your solution. Okay, so for Moh method, your analyte is the chloride ion or the halogen ion, okay, and this method utilize chromate as an indicator, okay, chromate. So here the method is applicable to determine chloride ion and bromide, but not for iodide or uh, thiocyanate, okay. SCN minus is thiocyanate. Okay, so here you can see during the titration, the chemical reaction involved is the formation of the silver chloride, okay, as the solid. Okay, the silver plus comes from the precipitating reagent mixed with the your analytes. Okay, so this is the simple chemical reaction, okay, during the titration. However, at the end point, you will have another compound as your solid, okay, as your precipitate, where the silver nitrate, the silver from the titrant, okay, mixed with the chromate, okay, mixed with the chromate, which is you use as an indicator, okay, and then it will form the silver chromate, okay. So this is basically the silver chloride you cannot see very clear, so you need an indicator, okay, to see the changes and to determine the endpoint, okay. So that's why you need to use chromate in this case. Okay, so the first drop of excess silver ion will react with the chromate indicator, the reddish precipitate, okay. So you will see in the Mohr method at endpoint reddish precipitate will be formed, okay. Okay, so after all chloride ion has been consumed to form silver chloride. Okay. However, this method can occur relatively greater titration error because it is difficult to observe the red color of silver chromate precipitate. It is not very um, uh, accurate. Okay, but still, it can be used. It can be applied. Okay. However, you can see also the yellow color of chromate ions. Okay, you can see that the color changes is not really we cannot see very clear. Okay, we can determine the changes of like the formation of reddish precipitate, okay, and then we stop or we take note the volume of the titrant, okay. And at present, this method is not widely used as other endpoint detection methods are now available. So they use a more advanced method, okay, instead of more method, okay. Okay, so what we can say about more method, it is a direct titration, and we can say that the endpoint is actually the formation of colored secondary precipitate, okay, secondary precipitate. The secondary precipitate is actually from the silver chromate, okay, silver chromate. And the indicator most commonly used is soluble chromate salt, like sodium chromate, potassium chromate, okay. Okay, now for more method in the pH effect. um, Basically, this method has to be performed at a neutral or weak basic solution of pH 7 to 9 or at pH 6, starting from pH 6, okay, until pH 10. This is due to the when this method performed in a very low pH solution, okay. So it will there will be no any precipitate will be formed, okay. So what we can expect that the chromate ion will be uh, in an aqueous form. There will be no reaction occur between chromate and the and silver ion. Okay, so that is the problem. And whereas for in a higher pH, which is a basic solution. So in this solution, there will be silver hydroxide will be formed, and this is not what we want, because we want silver chromate to be formed. Okay, so that's why at a very low pH and a very high pH, um, both solution is not suitable to be used. So in this case, you need to adjust the solution pH uh, in between 6 until 10, so you can get more accurate results. Okay, so this is the process or the observation before endpoint, at the endpoint, and after endpoint. Okay, so as you know that before endpoint, okay, you add the silver ion as for your titrant, and the silver chloride will be formed. However, this silver chloride is actually white precipitate. Okay, so you cannot see very clear. Okay, the color of this precipitate. Okay, however, when you add the chromate indicator, so uh, it will react with the silver nitrate, the excess in silver nitrate. So that's why you can see the color changes to become reddish at the endpoint. Okay, so what is actually happened at the endpoint? All the chloride ion has been consumed. Okay, and so what is excess at this endpoint is actually your titrant. Okay, the silver ion. Okay, so excess of silver ion react with the chromate, so it will give you this slight reddish color. Okay, so here is your endpoint. Okay, so basically what we can say that the silver chloride has been formed before the slight reddish color is observed. Okay, and after that, after endpoint, when you have a lot of excess silver nitrate, so you will get the stronger reddish precipitate. Okay, it will become more red color. Okay, in your sample solution. So as for your information, chromate indicator is a faint yellow color, as you can see in the slide. Okay, this is the clear yellow color of chromate indicator solution. Okay, then from this yellow it will become reddish color. Okay, now in order to determine your analyte, in this case is a chloride ion, okay, in your sample, so you implement the Mohr method. Okay, so for you to calculate at the end point, okay, so we will need another fixed value, okay, which is the equilibrium constant value, and in this case we will use KSP, or a constant for solubility product. That is what KSP. Okay, so we have two types of reaction. Okay, the first one is the formation of a silver chloride, and the other one is the formation of indicator. Okay, and this is actually what we call as the concept of back titration has been implemented in this Mohr method. Okay, so in our previous chapter, you already learned about the back titration, the definition of back titration, and in this part, you will learn about the application of a back titration. Okay, so here, what we can see here that the properties of silver chloride is less soluble than the silver chromate, so it will precipitate first. Okay, so that's why you can see that silver chloride will precipitate first. Okay, because silver chloride is less soluble. Okay, and silver chromate is a brick red in color, so it will give you a color changes. Okay, at the end point. Okay, another problem that we need to consider when we apply Mohr method, okay, is the consumption of indicator concentration is must be or at least 5 millimole per liter. Okay, this is because when the concentration of indicator is too high, so the endpoint will be advanced and the result will be low. Okay, and you cannot see the buffer reagent in your titration curve. Okay, so whereas if the concentration of indicator is too low, so the endpoint will be delayed and it will take a lot of time for you to determine the endpoint. So basically, when the concentration is very low, so you need to apply a blank test. Okay, what is blank test? Blank test is the analysis of sample without the analyte. Okay, and so this test can can improve the result that you get when you use the concentration of indicator is very low. Okay. So next, we proceed with the second types of precipitation titration, which is a Volhard method. So in this Volhard method, your analyte is chloride ion, and also we have another um, titrant, same titrant actually, and we use here the precipitating agent is silver nitrate in the same analyte, the same precipitating agent. And when you have a titration, okay, in this Volhard method, you will see that you require another precipitating agent. In this case, there is a potassium thiocyanate as your second precipitating agent. Okay, so basically the first the first chemical reaction that you can see from this slide. Okay, this is the one that we want. Okay, so we want Ag plus, okay, or silver plus silver ion plus with the chloride ion will form the silver chloride. Okay, this is what we want. Okay, and however, when you pour a lot of a high volume of silver nitrate, when you pour excess volume of silver nitrate in the sample, so we cannot see, okay, we cannot see the changes. So what you need to do is you use another precipitating agent. In this case is the silver night I mean sorry, in this case you use the potassium thiocyanate. Okay, so by the time the thiocyanate react with the excess of a silver ion, it will form another it will form a solid of silver thiocyanate. Okay, and after that uh, the excess of thiocyanate, okay, in this case the excess of thiocyanate, okay, it will um, mix with the presence with ion 3 plus. Okay, so in this case you can see the color will be changed, okay, due to the presence of ion 3 plus. Okay, so by the time ion 3 plus react with the thiocyanate ion, it will form a red complex. So that is your, um, you can determine the endpoint by doing the calculation when you can see any changes in color of your solution. Okay, and what we can say about Volhard method, this method is very sensitive, and basically it is a good result. Okay, so you can have a good result by doing by applying the Volhard method. Okay, now uh, there are two common problem when you apply Volhard method, okay, in precipitation titration. So basically, for the problem one, okay, the endpoint slowly fades because silver chloride is more soluble than silver thiocyanate. So the silver chloride will slowly dissolve and is replaced by the silver thiocyanate. And the way that we can overcome this problem is to filter off the solid silver chloride and left the silver ion in the filtrate. Okay, and the second way is to add a few milliliter of nitrobenzene with the silver chloride precipitate and shake. Okay, this is to avoid the silver chloride to be soluble and to change by or to replace by the silver thiocyanate. The second problem is there is a possibility of iron 3 plus to hydrolyze to form the iron hydroxide under alkaline conditions. Okay, so what we can do is to perform the titration under slightly acidic conditions. Okay, so basically we will advise uh, students to use or to perform the titration at a slightly acidic and slightly basic conditions. Okay, so for the endpoints of a Volhard method, okay, so you know that you use thiocyanate, okay, as your titrant, and you also use ion 3 plus as the indicator, okay. So what you can see from this titration is that at your endpoint, the red complex ion will be formed, okay. So this is the red complex is actually comes from the ion thiocyanate. Okay, so basically, the correct method to implement the Volhard method is that we before we do the second titration, okay, by using the second precipitating reagent, uh, you will filter off first the silver nitrate, okay, and then you do the back titration with the thiocyanate and iron 3 plus as your indicator. Okay, so this is the observation for Volhard method. Before endpoint, you will add a thiocyanate ion and and then the silver thiocyanate precipitate will be formed, and you can see very clear that the faint yellow color observed. At the endpoint, the ion, I mean the silver ion is completely consumed, and the excess of thiocyanate will react with the ion 3 plus. So the color changes will be a slight orange or a red color. Okay, so after endpoint, when you have an excess of thiocyanate ion in your sample solution, further formation of ferric thiocyanate, okay, you will see a stronger dark red color. Okay, so the dark red will be observed after endpoint. Okay, now for the Fahren's method, okay, for the third precipitation titration, uh, this is the process, okay, for the Fahren's method, and for this Fahren's method, your analyte is same like chlorion, okay, and you also will use silver nitrate as your titrant, and your indicator is fluorescence. Okay, the fluorescence and its derivatives, or this is a group of weak acids. Okay, so for Fahan's method, you will use these kinds of indicator. Okay, so it is more simple than the for hard method. Okay, so let's look for the process. You can see before equivalent point, you add the silver ion into your sample, and then there will be form of silver chloride precipitate. Okay, so at equivalent point, you can see that the silver ion has been consumed, and once after equivalent point, you will see the dyes that you use as indicator. In this case, is fluorescence and its derivatives adsorb on the silver chloride surface. Okay, so what we can see here is that it use adsorption, okay, to shows the formation of silver chloride in your solution. Okay, so the excess of silver ion react with fluorescence to become reddish precipitate. Okay, so when you have only slightly alkaline to alkaline solution, this is just to avoid silver ion to convert uh, into silver hydroxide. Okay, because you know that silver hydroxide is precipitate, and we don't want this in our product. Okay, so you need to be careful when you do the Fahan's method. You need to control the pH value of your solution. Okay, so for the endpoint, you will see a red dye attached on the silver salt on the surface of the analyte precipitate particles. Okay, so this is a very simple method. Okay, and it use or implement the adsorption process. Okay, to show the endpoint. Okay, now we go for the limitation of precipitation titration. Okay, so the first one is a few number of ions such as halide ions can be titrated by precipitation method. Other than that, it's not practicable, and it's not uh, suitable to be used. Okay, uh, so that is the most commonly problem that we counter, okay, when we try to use the precipitation titration. The second point is co-precipitation may be occurred. Okay, by the time the precipitation form, by the time the precipitate form, it also will invite other compound or other components in the solution to uh, to um, to agglomerate, okay, in the precipitate uh, via co-precipitation process. Okay, so it will increase the impurity of your precipitate. Okay. Okay, next, it is very difficult to detect the endpoint. Um, in any titration, even though for acid-base titration, it is very difficult, okay, to detect the endpoint because we need to see the color changes by looking at the color changes in your solution. However, we can overcome this problem, okay, when we have a more advanced method to check or to monitor the color changes in your solution. And now we go for the application of precipitation titration. So basically, Moore method, Vohart method, and Fachans method has been widely used in any applications in food process or in uh, environmental chemistry and any kinds of field. Okay, can use these kinds of method. Okay, so for example, the first one is determination of chloride content in natural water. It is a, uh, process. They required the Moore and Volhard method. Okay, okay. Second example is determination of silver content in silver alloy. Okay, so they use the Volhard method. And the third one is to determine of halogen content in organic compounds such as food, organochlorine pesticide. They use Volhard method. Okay, so this is just the example of chemical reaction. Okay. The fourth, the precipitation can be observed when the salt is occurred and indicator is used to see the pH range. Okay, mostly used for neutralization of reactions. Okay, so by the time we want to monitor the changes of pH value, and we can use this precipitation titration. Okay, uh, for any kinds of neutralization. Okay, so basically neutralization reaction is a acid base titration. Okay, and fifth is the function of precipitation titration for the reaction when the titration is not recognized by the changing color. Okay, so basically when they have a problem in such way to determine the color changes, so they will use the precipitation titration. Okay, and the sixth one is we use the amperometric titration, and this is we uh, we implement the electrochemistry. Okay, and we can see and we can observe the potential. Okay, the potential as a signal, and use the suitable indicator. Okay, for this kind of titration. Okay, and the last one is it is used for determination of chloride by more methods using silver nitrate. Like for this example, okay, in this topic we use a lot of the number 7 example of application. Okay, now we're going to the last part of this topic. Um, I will show you on how to calculate in order to construct a titration curve for this kind of precipitation titration. Okay, so precipitation titration is the most common method to determine the halide ion concentration of aqueous solution. Okay, so in this titration curve, you will see three types of calculation. Okay, you will see three types of calculation that are required. Okay, in order for you to determine the before endpoint, at an endpoint, and after the endpoint. Okay, so what is actually the reaction or the calculation involved is the first one is pro-equivalence, second is the at equivalence, and the last one, the third one is the post equivalence. So basically, when we want to calculate, okay, when we want to determine the concentration of our analyte, okay, our analyte is a chloride ion, okay, just remember that. You need to calculate and you need to know the KSP value. Here is the KSP is the equilibrium constant solubility product, okay, for silver nitrate. Okay, just for at this slide, you can see the value is 1.8 times 10 to the power of minus 10. Okay, that is the value of KSP for silver nitrate. Okay, silver chloride, sorry. Okay, and you know the chemical reaction. Okay, 1 mole of silver ion mixed with 1 mole of chloride ion will form 1 mole of silver chloride. Okay, so you can see when at the end point, okay, you need to write the equilibrium constant expression. Okay, so in this case, the solid compound will be negligible. Okay, so you need to just simply um, put in the value for the reactant, and then you can simply calculate the concentration of your analyte. Okay. Okay, in order to construct a titration curve for the precipitation titration, you need to follow a few steps in order to construct the graph. Okay, the first step is first you need to calculate the volume of silver nitrate that you calculate from that you can identify from the experiment. Okay, so you need to know that the volume of silver nitrate is your signal. Okay, and you will observe that um, before at equivalent points and also post equivalent point. Okay. Okay, second is you need to calculate the PCL. In here, PCL is like pH. Okay, but in pH we use hydrogen as our analyte. Okay, hydrogen or the H plus, the proton, the proton as your signal. Okay, as your analyte. But in this precipitation titration, your analyte is chloride ion. That's why you need to calculate the PCL. So what is the equation involved with PCL is that PCL equals to negative log concentration Cl. Okay, so that is the concentration. That is the equation. Okay, that you need to know before you calculate any or you need before you calculate the value of PCL. Okay. So you need to know the concentration of chloride ion. Okay. Okay, so for the third step, you need to calculate at the equivalent point. The way you do calculation for equivalent point at equivalent point is different with equivalent at before the equivalent point. In this case, at equivalent point, you need to use the KSP value. Okay, you need to use the KSP value. Okay, and then you need to do the same method on how to determine the at equilibrium. What is the concentration of chloride ion? Okay, so that is the things that you need to very careful by the time you want to do calculation. Okay, so at the equivalent point, you need to use the KSP value. Okay. Okay, for the fourth step, you need to calculate the PCL after the equivalent point. So in this stage, you will use the same method on how to calculate with same method. Okay, with before the equivalent point. Okay, the same method. Okay, so after you do calculation and then you need to take note all the volume of silver nitrate used and the PCL value that you calculated. Okay, so after you have this value and then you graph, and then this is your uh, observation. Okay, this is your result. So what we can see is that your endpoint is or at equivalent point is at like pH more or less like 5, and the volume of silver nitrate is at about 25 milliliter. That's all for chapter 8, and thank you for watching. Bye.